much, Alec, Harry, and Owen, for your. And what's fascinating about solar activity is we see it happening on other planets as well, not just the Earth. Saturn, for example, its magnetic field is 600 times more powerful than that of the Earth. And and certainly it kind of nicely dovetails with the guys' talk tonight and the talk about Saturn. Ask someone to draw a planet, and chances are they'll draw something that will make you go, ah, Saturn. Like, it's iconic, an icon in popular culture. And once you see Saturn through a telescope for the first time, you'll never forget the thrill of the view. And we can only surmise that Galileo was similarly awestruck when he first used his 20 power per speculum to take a view of Saturn in the spring of 1610. But he was also puzzled, because when he looked at the planet in that low power scope, he saw what he's termed appendages or ears attached to the planet. It seemed to have a triple nature. He was complete, and the puzzle only deepened more 2 years later, because these attendants that were beside Saturn completely disappeared. We now know that the rings went edge on in that year, but he wrote to the Duke of Tuscany, perhaps Saturn has eaten his children. It was an allusion to the myth of the Titans eating his offspring before they grew up, to prevent them from challenging his authority. In the myth, he ate the children whole and regurgitated them again after a while. But this painting by Peter Paul Rubens in 1636 depicts that myth. And you can see it's a rather grotesque depiction because it's very graphic in a sense. But what's interesting about it is, if you look at the top of the image, you can see the triple planet that Galileo observed through his telescope, depicted right there in Rubens' painting. Though, of course, in 1636, Galileo, by that stage, he had improved on his original telescope design and built more powerful instruments. So he began to get hints of the planet being surrounded by some sort of ring or handles. The puzzle continued for a few decades until 1655, when Christian Huygens published an anagram where he explained what he had observed around Saturn. Huygens had built his own refractor telescope, magnifying about 50 times, and it was powerful enough to allow him start coming up with solutions as to what people were actually seeing around the planet. He also found Saturn's largest moon, Titan, the second largest moon in the solar system, at about 5,100 kilometers across, bigger than the planet Mercury. In 1659, Huygens published a book called Systema Saturnium, a small 96-page book, but outlining more or less deciphering the anagram he had published 4 years earlier. In that he had observed Saturn had a ring, thin, flat, and nowhere touching the globe of the planet. He also published a solution for why the rings sometimes disappeared, or in other words, went edge on. In the diagram, he shows Saturn at different points in its orbit around the sun, and at each of those points, what our view of the planet would be from the perspective of an observer on the Earth. And it elegantly explained why the rings seemed to disappear. Christopher Wren, a few years earlier, had similarly come up with the idea that Saturn was surrounded by a ring, but he was unsure whether the ring was attached directly to the planet or was separate itself. And when he saw Huygens' elegant solution, he decided not to publish. He's quite happy to let Huygens take the credit. More discoveries soon followed. Giovanni Cassini discovered 4 moons around Saturn, and in the same period, Laplace was to suggest that Saturn has a number of smaller rings, not a single ring, which kind of dovetailed nicely with the observations that Cassini had made, that there was a gap in some of the rings. Herschel was to find the moon Enceladus, and also note that the planet was quite oblate or flattened at the poles because of its rapid rotation. He made an estimate of how fast the planet rotated as well. Moving on into the 19th century, we began to learn more about the planet. In the guys mentioned 1859 earlier. That was also roughly the year that James Maxwell published. While he was still a student at Cambridge, there was a competition called the Adams Prize, named after John Cush Adams, who had co-predicted the existence of the planet Neptune. And Maxwell published a small paper called On the Stability and Motion of Saturn's Rings. In that, he clearly demonstrated that the rings could not be solid. They were actually made of innumerable small particles, each individually orbiting the planet Saturn. Laplace had hinted at the possibility in his system of numerous ringlets, because Laplace had shown that a single solid ring could not be stable. If it was any way offset from the center of the planet, it would start wobbling out of control and be disrupted. But Maxwell approached the problem systematically based on the stability of the Saturn system. He surmised that if the rings have existed since time immemorial, then they must be inherently stable. And that was the premise on which he demolished previous theories as to what the rings were actually, well, the form of the rings. Some people had even believed that there might have been a fluid of some sort in orbit around Saturn. And the paper won the Adams Prize in the particular year that Maxwell submitted it. A few years, and Maxwell's theory was confirmed in 1895 when spectroscopic imaging was to be able to measure the Doppler shift of the rings and show that it was made up of innumerable small bodies orbiting the planet independently. About 10 years prior to Maxwell, Edouard Roche approached the problem of how did the rings actually form. And he suggested that a moon strayed too close to Saturn and was gravitationally torn apart. His basis is on, looked at the 2 different bodies, Saturn itself and the density of Saturn, and the density of a moon that would stray too close. And also he looked at the Roche being dependent on how well the material making the moon was bound together. And he found that within about 2.4 times the radius of Saturn, if an object strayed inside that point, then it would be gravitationally, tidal forces would rip it apart. And that Roche limit just actually happens to lie within ring system of Saturn. So it became the leading theory as to the origin of the rings. But as we see later, not the only theory. Coming into the spacecraft age, prior to the Voyager flybys, eagle-eyed Steve O'Mara, a US amateur astronomer, saw what he described as spokes in the rings of Saturn. But it required the Voyager flybys to actually see the spokes in close up. We now believe they appear only around the equinoxes of Saturn. Next year, there's Saturn is in equinox and we're coming into spoke season. The equinoxes are every 7 years or so because Saturn orbits the sun in about 29.5 years. They believe the spokes are electrostatically charged dust that is levitated above the ring system and held in place by Saturn's variable magnetic field. Magnetic field is variable because it's buffeted by the solar wind and it varies in intensity. The spokes last for about 2 or 3 rotations of the rings. The rings rotate at speeds of between 80,000 and 50,000 kilometers an hour. And we, as I mentioned, we're coming into spoke season when at a low sun angle on the rings, you can potentially see these, and the tilt of the ring is such that we can see across the disk of the ring itself. The Voyagers began to reveal a lot of secrets about the planet. They showed the braiding in the rings. They showed the shepherd moons, where 2 moons are shepherd holding the rings together, kind of shepherding the particles around Saturn as they orbit. And then we came to Cassini-Huygens, a joint European NASA mission, huygens was launched in 1997, reached the Saturn system in May 2004, deployed the Huygens probe, and then in 2017, after dramatic fly-throughs of Saturn's rings, Cassini was commanded to burn up in Saturn's atmosphere because of the risk. Well, it had run out of maneuvering fuel, but NASA did not want the risk of the moon or Cassini crashing on any of Saturn's moons and potentially contaminating them if they had the possibility of hosting life. I'm going to dwell a bit on Cassini because I'm actually not going to say much about the globe of Saturn itself, because the real drama is the moon system and the rings. Saturn has 146 known moons, with many more still to be discovered. About 130 of the moons are less than 50 kilometers across, and it's certainly way out ahead as the moon champion of the solar system. Jupiter is a very distant second with only 95 moons. So Saturn has an extraordinary retinue that Cassini studied and revealed to be literally full of wonders. Each moon it looked at was extraordinary, from Hyperion, which is extremely porous, very heavily cratered. It's almost sponge-like in that image there, but it's Titan that really garnered the attention. The Huygens probe parachuted into the atmosphere of Titan, spent about 2.5 hours floating down through the atmosphere, imaging as it's going. It essentially was an extension of our senses. It was looking at the terrain, the surrounding terrain as it descended. It was listening to the winds of Titan, and it was sniffing the air, the makeup of the moon. it's the only moon in the solar system with a very extensive atmosphere, a very opaque atmosphere because it's a smog of hydrocarbons, a very cold place. We now know that instead of lakes of liquid water, it has lakes of liquid methane. It also has, the atmosphere is much denser than Earth's. It's about 1.5 times denser on average than Earth's atmosphere. And in a way, those hydrocarbons are the constituents of the building blocks of life. Some have even speculated that when the sun expands to red giant stage, it will warm up Titan and life may develop on it. We just don't know. Huygens lasted about 70 minutes on the surface of Titan, and again relayed back extraordinary images of what looked rather like a beach scene with boulders in the distance. And we're going back. We're going back in 2028. Mission called Dragonfly will launch, arriving at Titan in 2034, where we'll deploy half-ton rotorcraft that will fly in Titan's atmosphere. It will fly up to 8 kilometers away from the lander, and after each mission, it will return to the lander and connect back into a docking station to recharge its batteries for its next flight. Dragonfly will have drills and other instruments on board to analyze the surface of Titan. It's going to be an extraordinarily exciting mission. And the fact that we instead of just being static like the original Huygens probe was, this will give it the ability to explore the surrounding terrain, and who knows what mysteries it will uncover, what questions it will throw up. Potentially life. Well, we just don't know. We anticipate with each of these missions to potential life-bearing worlds that one will hit the jackpot and find something that shows, okay, I can't say we're not alone because it'll just be microbes, but they're not Earth microbes. Whatever wonders were revealed in Saturn's moon system, Cassini's cameras gave us astonishing views of its rings, like this backlit, the sun behind Saturn here, backlighting the complexity of its ring system, a view that we can never see from Earth. The rings are, well, they extend out to about 285,000 kilometers from the surface of, from Saturn itself. Saturn's globe is about 120,000 kilometers wide. So it would fit essentially between the Earth-Moon distance, but leaving only a small gap. So it is quite extensive. Saturn can hold about 750 Earths. So it's quite a large planet. It's also the planet with the most extreme eccentric orbit of the gas giants. Its orbit takes it out to about 1.5 million kilometers, or billion kilometers closest point in the sun, about 1.3 billion kilometers. Its atmosphere, like Jupiter's, is mostly hydrogen and helium, but the globe itself is a bit more bland than Jupiter's colorful atmosphere. That's because it's a colder environment. Lower gravity also means the atmosphere is about 2 times thicker than Jupiter's atmosphere, and the ammonia layers that give Jupiter its various colors are much deeper in Saturn's atmosphere. So it can be bland visually at first when you view it through a telescope, but with patience you can begin to tease out detail. About every 30 years, white spots erupt in Saturn's atmosphere and can give rise to storms that spread around the planet. So there's a lot of interesting stuff going on with Saturn. But as I say, it's the rings we're really interested in. This is a table of the main ring features that I got on Wikipedia and added a few bits and pieces into it. And a diagram of the ring system. It doesn't include the Phoebe ring, which was actually discovered by the Spitzer Space Telescope. It's invisible in visual light, but in the infrared we were able to find it, and it extends up to about 200 times the radius of Saturn from the planet. It's a huge ring, and it's associated with the moon Phoebe. Impacts of micrometeorites on the moon chip off material that eventually goes into orbit around Saturn and creates this very extensive ring system. But to show how this is a system that interacts extensively with itself, that material begins to spiral inward in towards Saturn and settles on the moon, on the leading face of the moon, Iapetus, a moon that even back at the time of Herschel was known to be show a difference of 2 magnitudes depending on which side of Saturn you observed it. One side was surmised to be brighter than the other, and our close-up views with spacecraft has shown that to be the case. The leading edge of Iapetus is darker than the trailing side of the moon. And that material that settles from the Phoebe ring onto Iapetus, it causes ices on the leading side of Iapetus to sublimate, and they eventually condense at the poles and the far side of the moon, leaving a tar-like coating on the leading part of the moon. So it's an extraordinary interaction. Meteorite impacts also give rise to the ring that's associated with the moon Pallene, and also with the moons Janus and yes, thank you. So there is an extraordinary interaction between these. The rings are actually named in the order of which they were discovered. So the A ring was found first, the B ring second, and the C ring third. The rings are, to give an idea of how extraordinary they are, the rings are about 1.7 million times wider than they are thin. The main rings that we see are about 10 meters thick, but some of the other rings are actually up to 2,000 kilometers thick, but they're extremely faint, and you can't really see them visually through a telescope. On that scale, if you had a sheet of A4 paper, you would need to scale it up to about the length of a football field to actually see the sorry. Yeah, you need to scale it up to about the length of a rugby pitch and still have the same thinness of a sheet of A4 paper. From Earth, we see you can see some of the gaps, you can see some of the ring system, but some of the other rings really need the close-up views of spacecraft. I'll just show, the next slide shows some of moons that interact with the rings. A couple of these are really extraordinary. Pan, for example, some people have likened its shape to a walnut or a piece of ravioli. It's where the moon is orbiting within the so-called Encke gap and is essentially clearing it of material, though spacecraft images have found that there's a small ringlet associated with that the gap isn't completely clear. But the Encke gap is about 320 kilometers wide. Pan itself is about 30 kilometers wide, but this ravioli or walnut shape is because of a ridge of material right around its equator that it has accumulated as it's orbited around the planet. Atlas is even more extreme. It orbits inside the also close to the F ring, where it's accumulating material as it's going around. Then Pandora and Prometheus are the two moons that shepherd the F ring. This is Pandora in the bottom left, and it clearly shows the braiding within the F ring. But we now think that Prometheus is the primary moon responsible for maintaining the F ring and the intricate features that we see within it. An extraordinary sight was the view of the moon Daphnis. It's a moon about 7 kilometers, 8 kilometers wide, orbits inside the Keeler gap, but it oscillates up and down by about 20 kilometers as it's orbiting inside that gap. And as a result, as it's oscillating up and down, it's dragging material out of the ring plane up to about 2 kilometers high. And then as it passes on, that material slowly settles back down into the ring itself. Interestingly, the rings have an atmosphere of their own because of sunlight just breaking up water into hydrogen and oxygen, but it's an extremely tenuous atmosphere. If you were to condense that atmosphere out, it would form a layer only about an atom thick right across the whole surface area of the rings. I didn't say what the rings are actually made of. Pure water ice, except for traces of dirt, essentially. They range in size from grains of sand sized up to blocks about as big as houses, but on average, the average size of the individual particles in the rings is about the size of your fist. And this is a whole dynamic system going on. There's extraordinary interactions between everything, moons and rings, and even with Saturn itself, because the rings are not finite or not infinite, they're finite. They'll eventually disappear. Cassini found that there's what's called ring rain, where material, electrostatically charged material is following the magnetic field lines into Saturn and constantly raining down on the planet. The estimate that about a swimming pool's worth of material is infalling every half hour into Saturn. They'll last maybe 100 to 300 million years. The rings as well, Cassini also gave us an idea of the mass of the ring system. Saturn's moon Mimas is about 400 kilometers across. The estimate that the total mass of the ring system is about half the mass of the moon Mimas, but spread over an extraordinary area. Enceladus, another moon with the potential to support life. Close-up photos from Cassini showed geysers erupting from the south pole of Enceladus from fractures at the south pole, spewing hundreds of pure water ice hundreds of kilometers into space. In fact, that material spewing out is the reason for the existence of the F ring around Saturn. The F ring is pure water ice, but on the microscopic screens, the material in the rest of the ring system itself are macroscopic, sand grains to house-sized boulders, but in the F ring, it's purely just water ice. And again, with the F ring, we're seeing that ice migrating inwards and basically coating some of the other moons, such as the moon Tethys, which shows a kind of bluish tint on its leading edge from ices settling from Enceladus settling on its surface. They believe there's a subsurface ocean on Enceladus, and that hydrothermal vents maybe even below, on the seabed of that ocean. Cassini flew through some of these plumes and was able to taste the material that made it up and found that it was briny. So those salts may be life supporting. And it's another moon that people would love to get a mission back to, but we'd have to figure out a way of getting down those vents or drilling down through the surface. We don't know to what depths. We'd have to drill through the ice to get to the water, but certainly it's high on, essentially NASA's mantra is follow that water. And here we have an ocean. So going on to the origin of the rings and their age, that Roche had given the moon, a hypothetical moon, the name Veritas, again from mythology, figure in mythology that hid at the bottom of a well. And he's suggesting that the moon was torn apart after straying inside the Roche limit is still one of the leading suggestions. Cassini was able to show that the rings are actually quite young. It was believed that the rings may have existed from the formation of Saturn, but Cassini showed that if that was the case, the rings would, over the age of the solar system, would get heavily coated by micrometeorite dust and would darken as a result, but the rings are still quite bright. So that hints that the rings are quite young and are finite. Of course, there's still scientists arguing that they have existed from the time Saturn itself was born. We just don't know. Could they have come from a satellite that was unable to form? Instead of a moon being torn apart, could two moons have collided, or maybe a moon have been hit by a large comet nucleus? Another suggestion is that a satellite drifted in towards Saturn. Its outer icy layers were stripped off, and the core of the moon itself was absorbed into Saturn's atmosphere. Another theory in the last couple of years was that the rings are continually reborn from the recycling of temporary moons, because as that material is orbiting Saturn, all those chunks of ice are colliding with each other, some shattering completely, but others sticking together and beginning to aggregate, and eventually maybe growing to large moons, which are then smashed into each other again, and there's this continual renewal and recycling. And the interesting thing about that last theory is it's a process not just happening in Saturn, but the process that happened in our own proto-solar system, where grains of material gradually stuck together and gradually got bigger. Those clumps gradually got bigger and bigger, accreting more and more. Eventually, the planets that we know today were born out of that maelstrom. So it's interesting to consider that processes going on right now in the rings of Saturn are processes that happened in the early solar system and processes that are happening in proto-solar systems we're seeing around other stars today. Moving on to the last part of the talk is the disappearing act itself. Next year, the changing angle of the rings every 13.5 or 13.75 and 15.75 years, Saturn or the Earth crosses through the ring plane of Saturn, and we see them age on, and they appear to, well, they disappear, not wholly disappear. It's a bit more complex than that, because the sun angle on the rings can cause an effect as well. And I could call on Terry at the end maybe to say a few words about the 1966 ring plane passage. But just to give an idea about observing Saturn, this is an interesting photo that shows the scale of the planet seen through an eyepiece yielding of 100. And that's the lunar crater Tycho there. And you can see that at 100 times magnification, the planets look tiny compared to the terrific detail that you can see on the moon. So through a telescope, you really need to start, like if you want to really study the globes of the planets, you really need to bump up the magnification a bit. There's a few facts there about Saturn. 8 moons can be seen through an 8 to 10 inch telescope. Yeah, I've seen 5 so far, I think. Kind of different nights, but I've had the 8 inch Dobsonian out. But when the rings actually go edge on, it's a good opportunity to see the moon. It's easier to see the moons, because then the brightness of the rings, the glare off the brightness of the rings doesn't overpower the moons when they're close in. I originally thought there was only 7 moons possible, but then someone said Hyperion is brighter than Mimas and can be seen when it's near, because it strays so far out that it can be overlooked. But when it's in near the planet, it's a good opportunity to see it. And not just the eccentric orbit of Saturn affecting its brightness, but the rings themselves, when they're very wide open, as they were in 2017, the rings contribute almost a full magnitude of brightness to the planet's apparent brightness. And then it's much dimmer at the moment, because the rings are at such a shallow angle to us. This gives just a diagram from March this year up to December next year. It's from the British Astronomical Association, one of their observing sections. And I just added in a couple of lines showing when Saturn is at solar conjunction, or in other words, we can't see it. It's on the far side of the sun to us. And then at opposition, when Earth is between us and, or when Earth is between the sun and Saturn, and it's well placed for observing. Unfortunately, next year, when the rings go edge on, it's only 11 days after solar conjunction. Saturn would just be too close to the sun to see the moment the rings are edge on. Rather unfortunate, but things will begin to improve though as the summer goes on. By early May, Saturn is rising an hour before the beginning of civil twilight, and then as the year goes on, it'll observing opportunities will improve. But this wavy diagram here is showing the inclination of the rings to the Earth, and you can see that just towards the end of March is when they go edge on. But solar conjunction, as I said, is just a few days beforehand, and the planet really is too close to the sun to be seen. Now, potentially you could observe the planet in daylight. If you're a careful observer, you could pick it up in the scope, but you haven't a hope of seeing the rings edge on because the sky is just too bright, and you just won't see anything at all. The next diagram is kind of better. This is a good website here. It's a French website, that tiny URL link. It's basically a simulator that allows you to plug in any date and time, and it will draw a diagram of Saturn's ring tilt at that time. This diagram is, or these two diagrams are from the dates I plugged in. I plugged in May 6th, which is when the sun crosses the ring plane, and the illumination changes then. So essentially, the rings are just kind of like a black line across the disk. And then November 24th is when the rings are at their shallowest angle until like they won't be as wide again, or sorry, they won't be as narrow again until the next ring plane crossing. In fact, they'll be less than a degree tilted up to early 2026. So there's very good opportunities towards the end of next year. Even though we don't see the rings edge on, we'll see them extremely thin. And the sun angle then is about 3 degrees, I think. I have it written down somewhere. Oh, you have, yeah. Sun angle then is 3 degrees. So you'll actually see the shadow of the rings projected onto Saturn's globe, which is quite a fascinating sight. And that's just a table of the key dates over the next year or so for observing Saturn. And the last slide is the 1966 ring plane crossing, which was a triple crossing. And maybe Terry would like, I selected some of Terry kindly sent me some drawings he did with Patrick Moore at Armagh Observatory in 1966. I'd just like to add that Terry often says Patrick mentored him in astronomy, and I can honestly say John O'Neill taught me a lot of my astronomy. So it's just nice to acknowledge mentors. And yeah, if you don't mind,
sure,
describing that experience, Terry.
Yeah. How can I pay any extra, Terry?
Sorry?
How can I pay an extra?
First of all, I'd like to pay my own tribute to John O'Neill. I've known him for many, many, many years, and I could say a lot, but just one thing is a sort of a personal tribute: the total solar eclipse in 2017, which we went out to observe in America. He and Sarah made all the arrangements for us to go and see it at a very good site in Wyoming. And Sarah's family all went as well. But basically, they provided us with all the camping equipment, the tents, sleeping bags, ground sheet. We all went as a group and camped in adjoining sites. not quite on the center line, but very close. But basically, we called at Sarah's. I'm not sure whether it was her brother or brother-in-law, his house in Wyoming, sorry, in Colorado, and collected all the stuff, and then we all drove up and met at the campsite at a reservoir, and they laid on everything for us. So we didn't have to do anything except basically fly to Denver, hire a car. We had a great holiday while we were there as well. But basically, John and Sarah led on everything for that. And lots of other stories I could tell, but just that in particular was a really major contribution to getting a superb view of the eclipse. So very, very sorry to hear of John's passing. Anyway, this was an amazing occurrence. Now, 1966, I know you all absolutely unbelievable that I was able to observe anything in 1966. I'm not that old. I was obviously a child prodigy, which is stretching things a bit. Actually, my first observation was made at the age of 11, but that's by the by. The interesting thing about this was that the Earth passed through the ring plane 3 times. How does it do that? Well, you'll all probably know about retrograde motion. Okay, so ignoring the passage of the ring plane through the sun, which I'll mention in a moment, the Earth passed through the ring plane, and then because of its retrograde motion, it passed back again through the ring plane, and then it resumed prograde motion again and passed through the ring plane time. Now, this happened just after solar conjunction. The first observation that we got of it was when Saturn was only 19 degrees from the sun. That's typical of when you're sort of looking for Mercury, so it's in twilight. But I could give a whole lecture on this, but anyway, we decided on one night of exceptionally good seeing that it would be worth having a go to go and see Saturn. I don't think, oh yes, the time, 0405 UT, that would have been in summertime, so it was 0505 in summertime. We'd been observing Jupiter before, and rather than go to bed and get up, we stayed up all night and then headed up to the observatory to try and get this observation. And at that time, the rings should have been invisible because the sun was on one side of the ring plane and the Earth was on the other side, the dark side of the ring plane. And that first sketch there, which is one of mine, that's probably Titan in transit, or the shadow. I can't remember, but it's probably the shadow. You could definitely see the rings. There's absolutely no doubt about it. And Saturn was low down. As I say, the seeing that night was possibly the best I've ever encountered. So it was unbelievable just how steady it was, low down. And I managed to find the planet first. The finder was slightly out, and I had to find it in the main telescope. And the sun was there, and as soon as I got it in the eyepiece, you could see the rings. And I said, I'm not going to send Patrick, you have a look. Patrick went up, looked through the eyepieces. I see the rings. And I said, yes, I saw them too. Now, not the full extent of the rings, because the outer part was obviously too faint, but we could definitely see. And this band here is the shadow of the rings on the globe. I'm assuming, or at least the sun edge of it. This was later on, still on the dark side of the rings, but now they have shrunk slightly because they are now approaching the point where the sun is almost just exactly shining on the ring plane. So, yeah, sorry, yeah. The sun now only about a quarter degree above the ring plane on the other side. So we're still looking at the dark side of the rings, but because the solar illumination on the opposite side is now less, because it's almost exactly edge on, the part that we could see was much less. And then we're now on this one here seeing the side of the rings that is illuminated by the sun, but the angle is incredibly narrow. One of the slides you showed earlier showed it almost exactly like that. I have about 30 sketches altogether, so just a couple to John. Now, it's absolutely fascinating. How can you see the dark side of the rings? Well, there's 2 possible explanations. One is forward scattering, which is the sort of effect that you get with the anti-tail that we've seen with Comet, I'll not give you the full name, A3 will do. The other possibility is simply that light is reflected off the globe of Saturn, the surface of the sun, back onto the rings. So possibly a combination of both. I don't think I've ever heard anybody give an actual explanation as to what is happening there, but there was absolutely no doubt about another 8 or 10 nights in between that and that when we were definitely seeing the outside of the rings. Now, unfortunately, as you say, with this coming passage, we're not going to see it because it's so close to the ring, to the solar conjunction, but it's well worth following Saturn in a telescope as far as you can into early next spring, maybe early March and so on. The moons will be getting thinner and thinner and thinner and thinner, as you were also saying, because the rings are so thin and so faint. It's a chance to see the inner satellites that you've never seen before. We saw all of the satellites going inwards, Titan, Rhea, Dione, Tethys, Enceladus, and Mimas. And Mimas is about magnitude 12.8, I think, from memory. So to see it right close to the bright planet, really, you know, it's pretty good going. But when the rings are edge on and they're not contributing any light around the area where Mimas would be out about there somewhere, it is a chance to see them. And then after conjunction into probably May, June, whatever, when it starts to become visible again, you'll be seeing the other side of the rings. Have a look again when they're very, very thin and see what you can see. And unfortunately, I think the next ring plane crossing after this one is also going to be very close to solar conjunction. Yeah. So this one is about as good a chance as you get. I think maybe the one after that, which is 29.5 plus 29.5 years ahead, we're not going to see, but I'm not going to anyway. So it's fascinating. My favorite object of study is Jupiter, because it's always changing. But that was one of the most memorable series of observations I ever got, and I recommend you have a go at it. Okay.
Thanks. Yeah, that's very pointed out the dark spot there being the shadow of Titan, like the ring's edge on is an opportunity to see mutual phenomena of the moons where they can sometimes eclipse each other, or you can see Titan in transit. Some software will show such events visible from Ireland over the next year or so. Some observers have even reported brightening, knots of brightening along the rings.
We saw that, but you know,
it's difficult to kind of portray that as well. Yeah. So there's a lot of remarkable phenomena like to see during these occasions when the rings are very narrow, and we'll certainly kind of like keep an eye on the astronomy monthlies over the next 12 months or so, because they'll almost certainly be publishing articles highlighting the ring plane crossing and events that you might see. And the yearbook of astronomy that Brian Jones edits has a short chapter in it about the ring plane crossing, and there's a lot of stuff online. Like I noticed in one of your drawings, you sent them into Odell, and yeah, they're quite good books. I had Odell's book at one point, but it's in someone else's collection.
Giving it away like the rest of your book.
But I got all these ones in the Cosmos. These are very good. A lot of them are written by William Sheehan, a well-known astronomy historian, and he does talk a lot about the early observations of Saturn in that book as well. And then like the annuals are out already in the shops, the 2 guides to the night sky for the year ahead. So definitely, but I'll do up an article for Orbit on the talk, and hopefully we'll get some clear nights.
I wish I was looking at that. Listen, thank you very much.
Very welcome.